Okay, we're back. This is Techmath2. We're looking at 6.4 in the red book. We're looking at number 37. We are dividing radicals. So we're going to take, and just like when we multiplied them, where we put them all under the same roof, we're going to do that. And then what is that going to turn into? That's going to be the square root of 50. And now we have to do perfects and leftovers, or you can break it down into its primes and get them out two at a time. All right, so then this is the square root of 25 times the square root of 2. That's a perfect, that's a leftover. So you can't just do anything that multiplies to be 50. You can't just do 5 times 10, because 5 isn't a perfect square and 10 isn't a perfect square. So that doesn't help me. You need the first one to be a perfect square, and it is, in this case, 5 square roots of 2. Okay. Let's look at this one. They want the cube root. 128 divided by 2 is 64. And that happens to be a perfect cube. You can put that in your calculator, 64 to the 1/3 power. And then hit enter, and it should kick out a 4. Right? Because 4 times 4 is 16. And then times 4 again is 64. All right, so for 41, they just want us to do whatever you can simplify, but you're not really, in algebra usually, we're simplifying, we're rationalizing the denominator, where we're not allowed ever to keep a square root in the bottom of the fraction. But here, they just want you to do whatever you can do. So look, you do the square root of 7 on top, the square root of 4t to the 6th on the bottom, and then the square root of 4t to the 6th, that's perfect and imperfect. So 2 and t to the 3rd. Remember, you divide powers by the index. And so it's the square root of 7 over 2t to the 3rd. So algebraically, we would be fine with that answer. This one, not so much. This one, it's the cube root of 64, which we can do. Oh, wait, no, wait. Yeah, right? Yeah, we just did it right here. It's 4. And then the cube root of 3ax, which you can't do anything with. So that's just 4 over the cube root of 3ax. And so for this course, that's fine. We're not rationalizing the denominator, but in algebra, this is a big no-no. We wouldn't let you leave any kind of root, square root, cube root, 4th root, 5th root. Nothing is ever allowed in the denominator like that. And so then we'd have to multiply top and bottom to fix it. But for this course, you can just leave it. All right? Cube root of 1, cube root of b to the 6th is perfect. Cube root of a is not. So now look, I can take the cube root of 1. That's just 1. 1 times 1 times 1 is 1. So that's out. B to the 6th, you take the cube, or the cube root of that. That's b squared. You divide. 6 divided by 3 is 2. And then the cube root of a we can't do anything with. So you just leave it like that. Again, if this were an algebra course, I'd have you multiply top and bottom by the cube root of a squared, and it would be 1 cube root of a squared over b squared a, or a b squared. But you don't have to rationalize the denominator. You just leave it like that. This guy, what's going on here? Square root, everything's perfect except there's one little leftover on the top. Because the square root of 64x squared, that's perfect. But then times the square root of x, that's left over. And the square root of 9y squared, that's all perfect. So that little stinker is going to get left out. But 8x, square roots of x, because that's still left over, 3 isn't a perfect square. 9 and y squared, so that's 3y. And that's that. All right. We're going to look at one more problem in this section, 6.4, that requires us to factor. So you got to call back on your sweet factoring skills here. We have the square root that's just on the numerator of 9p minus 9q over 3q. So look at what we can do here. We can factor out a 9. Remember, factoring is like undistributing. It's like the distributive property in reverse. So instead of like 5 times 3x plus 2, and you take the 5 times that and the 5 times that, you get 15x plus 10. When you have 15x plus 10, what you can do is factor out a 5, where you figure out what comes out of both of them, you write it down, and then you divide it out. So 9 will come out of both of those, so I write it down out front. I divide that by 9, I get 1p. I divide that by 9, I get 1q. It's still over 3q. Now look at what I can do. Now that it's being multiplied, I can say that's like the square root of 9 times the square root of p minus q. So what I did not do, is I didn't distribute a square root over a plus or a minus. So I didn't take the square root of 9 and do that, and the square root of 9 and do that. I factored it out. Now it's being 9 multiplied by this binomial, and then now I can separate it into 2 different little square root problems. So this is 3 times the square root of p minus q over 3q. And now both of those 3's are on the outside, so you can cancel them. Again, another very common mistake. Our students try to pick off things. They're like, oh, this q will take that q out. No, it won't. It's being added and subtracted 1, so even if there wasn't a square root on it, you couldn't do it. And it's not under a square root, so definitely you can't do it for 2 different reasons. You can't cancel things that are being added or subtracted, and you can't cancel things that aren't both under a root, like a square root or a cube root. 4th root. All right, and we'll look at the last part of 44. We have st over the cube root of s cubed t. All right, so look at what happens. We can fix this into perfect cubes and leftovers, so st on the top stays st. But this becomes the cube root of s cubed times the cube root of t. Can't do anything with the cube root of t, but this, right, that's just s. So I have st over s cube roots of t. And now look at what happens. The s's are both on the outside and being multiplied. That's being multiplied by that. That's being multiplied by that. So we can cancel them off. The t over the cube root of t can't touch it because this is on the outside and this is stuck in prison, the cube root prison. So they do not get to mingle or cancel. All right. And that is 6.4.